This is exam 2 for physics 151. A cart begins with a speed of 4 meters per second at the top of this trajectory, and then I want to know where does it have the lowest speed? So where it has the lowest speed is where it has the least kinetic energy. It has the most kinetic energy down here, so this is where I have the highest speed. Where it has the highest kinetic energy is where it has the lowest potential energy. So it has the highest speed when h is equal to 0 because the potential energy is equal to 0. So now I'm looking for where I have the lowest speed is where I have the highest potential energy. So that's going to be up here because up here h is at its max. That means U is at its max. That means that the kinetic energy is at its minimum. You move an object to a mass m to a height h. What work has been done? Work is equal to force times displacement. Your force is your weight, and your distance is your height. That was from the notes. An engine is about 25% efficient, converting fuel to work. The engine does 50 joules of work. What is the energy of the fuel consumed by the engine? So 50 joules is the usable work. 50 joules is 25% of the total fuel consumed. That means 50 is equal to 25% times my total energy, and 50, let's see, is equal to 1/4 of my energy. So my total energy is equal to 50 times 4, or 200 joules. Friction does negative work because it acts in the opposite direction of the object's motion. You exert 4,000 joules of energy to move a 10-kilogram object from ground level to 40 meters. How much energy is required to move 20 kilograms to a height of 20 meters? So here I'm looking at the potential energy, gravitational potential energy is mgh. You can do this in a couple of ways. I'll look at it this way first. I'm doubling my mass, so I have a factor of 2 with my mass, and I'm moving it from 40. I have half the height. So doubling the mass, having the height, that means that my energy is going to remain the same. There's another way that you could have done that. You could have just calculated U for each one, right? So I see that in the first one, it's 10 kilograms times 10 meters per second squared. That's the acceleration due to gravity, times h, which is 40 meters. That's equal to 4,000, which we know, right? That's what it says there. And then I can do a similar thing for the next one. 20 kilograms, 10 meters per second squared, 20 meters. That's also equal to 4,000. So 4,000 joules. A couple different ways you could have done that. Number 6, the answer is lipids or fats have the most energy. You expend most of your energy in metabolic processes. This is the BMR, the basal metabolic rate. It's usually about, I don't know, 1,500 calories, which is most of your energy that you expend in a day. Um, on a rare day, I know like if I have a really active day, my BMR and my uh, caloric use of for activity can be about equal, but that's not typical. Like on a typical day, my my total metabolic rate is about 2,000 calories. So most of that energy is just going towards living, your breathing, your brain, your lungs, your liver, all those organs. Primary means to lose heat is radiation. Which of these is a means of heat loss? Okay, so sweating is a means of heat loss by evaporation. Dilation of blood vessels. So dilation means that the blood vessels open up, and so blood rushes to the skin and releases heat via radiation. Forced convection can be a means of cooling, like you stand in front of a fan, and drinking cool liquids can help you to lose heat. Space blankets are thin reflective plastic sheeting that people use to keep warm after long races, emergencies, or other events where they need to warm themselves. These blankets mostly minimize heat loss due to radiation. That's why they're reflective, by the way. So you often see those space blankets. They don't have to be reflective. In fact, they're not metal, they're made out of plastic. So it'd be just as easy to make them black or blue or whatever you want, put your logo on it, but they make them reflective because it reflects the radiation coming off of your body, the infrared radiation coming off your body back onto yourself. Which of these describes the energy? Well, this is going to be latent heat. It's one of those, latent heat to transform a liquid to a gas. Well, you want to think vapor. Anytime you see gas, you think vapor. So C. Determine the energy content of a food item. A food scientist explodes a sample of the food, for example, fruit cake. We listen to that thing about fruit cake, in a container of water. Then they measure the change in temperature of the water. That change in temperature is proportional to the caloric content of the food item. What is this device? So what they have is they have a device that looks like this. There's usually an inner chamber and it's capped off. And then you have water inside of here, and then you have your little food item right here, and you somehow set it on fire, you explode it, so it ignites like you're burning some fuel, and then that causes the temperature of this water to rise. And by measuring the amount that that temperature rises, Q is equal to mc delta T. We can measure this. I know the mass of my water. It tells us how much energy was put into that water. And by doing that, you can determine the energy of the food. This is called a calorimeter or a bomb calorimeter because you're actually exploding the stuff inside the calorimeter. Which of these is a true statement? Is it possible to have steam? No. It has to be at or equal to 100 degrees Celsius. At 80 degrees Celsius, water is just water. It's a liquid. The freezing point of water is 0 degrees Celsius? Yes. A change in temperature of 1 degree Fahrenheit is bigger than a change in temperature of 1 degree Celsius. So let's think about our thermometers here. They start at the freezing point of water. In the Celsius scale, the freezing point of water is 0 degrees. In the Fahrenheit scale, it's 32 degrees. Up here, the other reference point is the boiling point of water. That would be 100 degrees Celsius or 212 degrees Fahrenheit. Now, I only have 100 degrees between 0 and 100, but I have 180 degrees between 32 and 212. So a change in 1 degree Fahrenheit is actually smaller than a change in temperature of 1 degree Celsius. So that's wrong. The Kelvin scale is not based on the freezing point of water. It's based on absolute zero and the triple point of water, which is a point wherein water exists as all three states. It's a temperature very close to freezing, just slightly above freezing, where water exists as a solid, a liquid, and also as a vapor. So the answer is, what is it? Just two, I guess. Yeah, B is the only one. Heat transfer by convection is between two, can be increased. What can you do increasing in convection? Remember, convection is forced flow of a fluid. So if I increase the airflow, that will increase it. This will not increase it, contact, because that would be conduction. Reflectivity, that could change our radiation, and Laura's doesn't really have, well, yeah, it doesn't affect heat transfer. So one only. Okay, the following describes thermal conduction, and I'm told that it's 2 kilocalories per second. So this is 2 kilocalories per second. What happens if the new material has twice the thermal conductivity? So if I double this value, that means I have to double this value, so that would make it 4. Which of these helps to equalize pressure between the inner ear and the outside body? That's this tube right here, and that's called the eustachian tube. What part acts as a lever? This should be lever, number 17. I'll fix that. Uh, to increase a force. Okay, those are the ossicles. Those are little bones in the body, and they act as a lever so that, if I apply a force down here, I get a bigger force down here. It also acts pneumatically, so applying Pascal's principle as well, where I have a smaller area and then a bigger area, and that also increases the force. Consider this figure of the ear, which serves the same purpose as the diaphragm in a microphone. Well, the diaphragm of your ear, which your ear is a microphone of sorts, the diaphragm of your ear is the tympanic membrane, or the eardrum, and in this figure, that would be right here, number 4. The tympanic membrane is part of the middle ear. Be careful, you might have put outer ear. You might have put inner ear actually, but it is part of the middle ear. Consider these waves. Which is the loudest? So we have four sets of waves, and they're different by frequency. For example, this is high frequency. This is low frequency. They're also different by amplitude. This is high amplitude. This is low amplitude up here. So what's important for loudness is only the amplitude, not the frequency. Now the frequency will impact how a sound affects you. Like a certain frequency of sound might impact your ears more, but it's not that it's louder, it's just because your ears are more sensitive to those frequencies. So C and D had the same loudness. String on a guitar is a tension of 10 newtons. If I increase the tension by 20 newtons, by what factor does the pitch change? Give me just a second, I want to pull up your equation sheet. Okay, so the relevant equation here is this one right here, the 1 over 2L T over mu square root of T over mu. So if I think about this, F is equal to 1 over 2L square root of T, that's the tension, over mu, which is the mass density. So if I increase the tension by a factor of 2, I'm increasing this by a factor of 2. Now I have to increase this by a factor of square root of 2. So C is the right answer for 21. The speed of sound increases as the elasticity of the medium increases. That's a true statement. Which of these media has the highest elasticity? All right, remember the elasticity and the speed of sound will increase as I go from gas to liquid to solid. So I'm going to have my solid steel. Has a much higher elasticity and a much higher speed of sound. 80 decibels should be how many times as intense? All right, so remember to do this. I do 80 minus 50. That's equal to 30. And I get rid of the 0, and I take 10 to the third. 10 to the third is 1,000. So an increase in 30 decibels means an increase in intensity by a factor of 1,000. Remember, the ear is sensitive to a wide range, 10 to the 12th magnitudes of sounds, sound intensities. So we use a logarithmic scale called the sound intensity level in order to measure that. A glottal stop occurs when you say the k, 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 k sound, when you hold your breath, when you whisper to someone. Now, your glottis is open when you whisper to someone. That's why you have that breathy sound. It almost sounds like you're breathing. Or when you sing a pop song. Uh, I don't think I know any pop songs. Anyway, 1, 2, and 4 is B. Noise canceling headphones operate because of interference, which is when I add these two things together. This is my noise. This is the sound generated by the headphones. So it makes this interfering sound that cancels out the noise. So interference of sound waves. All right, here, what is my wavelength? I'm just gonna go from right here to right here. You can pick any 2 points. So a little bit above 2 to a little bit above 8, so that's going to be 6. What type of graph is this? The important thing here is y and x. Really, this is the most important axis. Since it has a position on that axis, it is a snapshot. If it were time, it would be a history graph. A wave has a velocity of 3 meters per second with a wavelength of 6 meters. So v is equal to 3. Wavelength is equal to 6 meters. And I know that this is equal to wavelength over period. So 3 is equal to 6 divided by period. I want to know the period, that's T, so that's equal to 2. Fundamental properties of matter include mass and charge. An oxygen has 8 protons. How many electrons does an oxygen cation have? That's a positive ion, so it means it has more, fewer electrons than it does protons. So it's going to have 7 electrons. Look at this, kids. What's her problem? She has an excess of negative charges in her hair. The positive charges on her hair have not moved. In fact, positive charges don't really move at all in an object usually. The back of her head is positively charged. That's not true. And the day is really, really humid. That's not true either. In fact, you would get the opposite effect if you had a large humidity. You could say that the day is really, really dry. That's probably the case. That's almost certainly the case. Remember, because water is a polar molecule. And polar molecules are slightly positive on one side, slightly negative on the other, causing them to take away excess charge. What can you say about these charges? They repel one another. Well, I can say that they're either both positive or they're both negative. So D is the right answer. D and C are sort of correct, but it could be either. 2-point charges are 4 centimeters apart. They're moved to a new separation of 2 centimeters. By what factor does the resulting mutual force charge between them change? So F is KQQ over D squared. What I'm doing is I've moved them from 4 to 2, so I have a factor of a half here. That means my force increases by a factor of 4. So I have these charges, and then I move them closer together. If my forces are like this, they've now increased by a factor of 4. Here are two parallel charged plates. What is the direction of the electric field? Electric fields always run from positive to negative. You can imagine this by saying, what if I have a positive charge? It will feel a force in that direction. Positive charges feel a force in the same direction as the electric field. What if I put a negative particle here? It's going to move to the left. So B is the right answer. In a neuron, the potential inside the cell is usually negative. So the resting membrane potential is below 0. What are these purposes of a nervous system? Let's see, so sensory input, integration, and motor output, not vision. So 1, 2, and 4. Consider this figure of a neuron. Which part of the neuron passes on an electrical signal to the other neurons? That's going to be out here, number 4. And what part is called the dendrite? That's going to be, these are called the dendrites. The E-meter used by Scientologists measures the resistance of the human body. Now, I'm not, the next best answer would be current because the e-meter does measure current, but the body doesn't have a current, right? The body has a resistance. So it measures the current in order to, or to figure out what is the resistance of that body. Which of these has units of joules per coulomb? That's an energy per charge. That would be potential difference, not potential energy. Potential difference. So remember here, this is newtons, this is joules, this electric field is a newton per coulomb, and then this is a joule per coulomb. This diagram represents a charged particle moving from low to high potential. What is the sign of this charge? So remember, positive charges will tend to move from high to low, but negative charges move from low to high. So that is a negative particle. Two positive particles, which are separated by 2 meters, have potential energy of 8 joules. If you move them to 4 meters apart, that is twice as far apart, what happens? So K, Q, Q over D, that's on our equation sheet. It's right here, KQQ over D. If I double this, that means I'm having this. So it was 8 joules, now it's going to be 4 for number 43. Which of these are units of current? Currents are coulomb per second. Power is an energy per time. Resistors resist or limit the flow of electricity, and capacitors store charge. A circuit consists of a battery and resistor. If I increase the resistance, what happens to the current? Well, resistors resist the flow of electricity, so the current will decrease. And then my favorite class, I think it might be this class. I really do like this class. I like how we combine physics of the world and combine it with the human body. I think that's really fascinating. There are a lot of applications in the human body. Okay.